All right, you guys, today we're looking at 5-6 for the remainder and factor theorems. Honestly, actually 5-6 is probably one of my favorite days as far as things go, because we start kind of getting away from the more challenging factoring. We actually get to use synthetic division to kind of help jumpstart our process, which tends to make things a little bit easier, all right? So that's some good news there. All right, so the first thing we're going to talk about is synthetic substitution. Synthetic substitution is related to division, okay? So we went over this process here between long division and synthetic division. We discussed both of these in section 5.2, okay? And you know, you can notice the coefficients are there and the remainder is all there. When we're dividing, everything works out, all right? So we have x minus 3, we divide it by x minus 3. So both problems, we get the same result, it just looks differently on how we get there, okay? Please note right here, when I do direct substitution, so that's when I plug a number into a function. That's what I call direct substitution. And I'm actually going to write that in there, substitution. All right. And that's something we've done before. So if I said evaluate the function at 3, you take 3 and plug it into your function. Notice our function in this case is exactly what we're dividing by. 3x squared plus 5x plus 4. Okay. When I plug in a 3 directly, look at your answer. It's -8. When I plug in 3 to synthetic substitution, I also get -8. Huh. Coincidence? I think not. And that brings us to the first key point of the day, which is the remainder theorem. The remainder theorem says that when we divide a polynomial by x minus r, the remainder we get, in this case it was -8, is the constant of our polynomial, all right? Which is essentially what our function equals at that value, all right? So we're gonna go into a few problems. You don't need to really know that by heart, but just know that synthetic substitution and direct substitution give you the same value of the function, all right? So first things first, we're gonna find f of 2, and we're gonna do it directly. All right, so how we do it directly, we plug it in. So we have 3 times -2 to the 4th plus 2 times -2 squared minus 5 times -2 plus 7. All right, so we wind up with 2 to the 4th, which is 16, times 3 is 48, 4 times 2 is 8, -5 and -2 is 10, and then 7, so we have 56, 66. We wind up with the function's value at -2 is 73. All right, are you ready to have your minds blown? Well, let's evaluate synthetically. So we plug in -2, we have 3, we have a 0 as a placeholder, then we have 2, -5, and 7. Oh my gosh, this is so exciting. So exciting. All right. So synthetic division, remember what we did back in 5.2, synthetic substitution is the exact same thing. All right. So we drop the 3, then we multiply. -2 times 3 is -6. 0 plus -6 is -6. -6 and -2 is 12. 2 and 12 is 14. 2, or -2 and 14 is -28. -28 and -5 is -33. -2, -33 is 66. 66 and 7 is, oh my goodness, this is like insane. All right, so whether we do direct substitution or synthetic substitution, notice we get the same result. The answer or my function's value at this point is 73. Okay, so kind of thinking about that. My function's value at a given point can be found using synthetic substitution. You know, I talked this morning, I don't know what the deal is. All right, so let's think about this. As we're tracing our function, at -2, we're up at 73, and then all of a sudden, if I can get this value to be 0, that's going to be an intercept on my graph. Right? My function's value. So if I plugged in, this point and got 0, that means I would be an intercept on my graph. Oh my gosh, it's like I knew what was coming. All right. So what we can do is we can use synthetic division to help us solve and factor polynomials. All right. If we take our polynomial and we were to divide it and get a remainder of 0, I know that what I divided by and my quotient are factors of the polynomial. Okay. And that's what the factor theorem says. It says if we divide and we get a remainder of 0, it is a factor of our polynomial. All right. And that's what the second half of the day is all about. Okay. So we're going to use this idea to actually solve. Okay. So I have my polynomial here, and I'm given one of the factors. All right. So let's plug in 3 synthetically, and let's go ahead and solve. So what I'm going to do is I'm going to set up my coefficients 1, 4, -15, -18, and I'm going to use synthetic substitution, and I'm going to make sure my remainder is 0, because then I know x minus 3 is a factor of my polynomial. Whoops. That's not a 3, that should be a 1. I'm going to do 1 times 3. 4 plus 3 is 7. 7 times 3 is 21. -15 plus 21 is 6. 3 times 6 is 18. -18 and 18 is 0. Oh my. And then if we think back to section 5.2, I know that the resulting coefficients are part of my quotient, x squared plus 7x plus 6. Which means my function is x squared plus 7x plus 6 times x minus 3. And oh my, I know factors of 6 that give me 7 are 1 and 6. So I could factor that again. And oh my, look at that. We just factored the polynomial using synthetic substitution to get us started. Oh, brilliant. All right. You don't have to do this today, but I'm going to show you what we're doing tomorrow. Okay. Everything we just did except we're solving. So your equations always equal 0. And then we're going to find the intercepts of my graph. So what I just did in red is actually going to be less than 5.7. Just so you know. So today is just using synthetic substitution to evaluate. All right. And using synthetic substitution to help us factor, which is eventually going to lead into solving with sections 5.7 and 5.8. Just remember with synthetic substitution, you guys, your remainder is the value of the function at that number. Okay. So at 3, my remainder is 0. That means the coordinate 3, 0 is a point on my graph. Okay. If you have any questions, your assignments on the bottom, chime into the discussion board or live feed, or even during office hours on Wednesday. I'd be happy to help. Best of luck with things. Again, if you have any questions, let me know. Otherwise, today, use synthetic substitution to hopefully help the factoring process. Best of luck. We'll see you around.